So today's lesson's algebraic reasoning, which I'm sure makes no even sort of sense to any of you really. But let's think about solving an equation. Okay? So take a look at the exploding head poster. First step, remove parentheses. How do we remove parentheses? Distributive property of equality, right? We use a property of equality. That's kind of, can I say that's our justification? Like that's the reason we can do it, right? How do we, when we combine like terms, we're just simplifying things, aren't we? Like 2x plus 3x, that's the same as 5x, isn't it? Isn't that just a simpler way to write it? Okay. When we remove a variable from one side or remove a constant from one side, we're either adding or subtracting a particular amount to both sides of the equation. That's the addition property of equality and the subtraction property of equality. Okay? And then the last step, reduce the coefficient to 1, we're either multiplying or dividing. So that's another property of equality. So when you first learned to solve equations, you talked about these properties of equalities, but then it came down to basically whatever you do to one side, make sure you do it to the other side. Something like that, right? Okay? Well, we need to do more than that. We need to think about these properties that we're using each time. So I'm just going to write an equation that I'm just making up as I go along. And make sure it's sufficiently awful. Okay. We have, every time we have a new equation, okay, so as we solve this, and we keep getting new equations each time, we have to have a reason, we have to have a justification for where that equation came from, how it came about. Even the first one, we have to have a justification. So, this is the easy one. This is given. So this equation, where'd it come from? Well, it was given. Okay? So now we're going to start solving it. And what's the first step? Okay, and I'm going to do that. So negative 3x subtract 15 plus 7 equals 9 subtract 3x. What? Very good, subtract 2. Now, what property got me from here to here? Okay, the distributive property. I'm going to abbreviate. The distributive property of equality. Okay? All right, what do we do next?
Like terms.
We add like terms. Now, this one's a little different. I'm just going to do this. Let's see, that would be negative 8. And 9 and negative 2, that's 7. That step is not a property of equality. I'm simply rewriting each side of the equation in a simpler way. Does that make sense to everybody? So all we're doing there is simplifying the equation. We're not using a property of equality. We could just say simplify, but I would like you to say that you're adding like terms. But if it just says simplify, that's what's happening. We're just writing it in a simpler way. Okay? Okay, now what? Oh, don't tell me. Oh, this is horrible. What's going to happen when we remove the variable from one side? We're going to get, if we add 3x to both sides, we're going to get a false statement with no variables. What does that false statement tell us? No solution, right? There's no solution to this equation. I don't want that to happen. That was horrible luck. Should have watched that better. But no, that was a 4 the whole time. Okay, so now, why did I make it a 4? That was a bad idea. 2. Good thing it was a 14. All right, we don't want the variable on both sides of the equation, do we? So what can we do here? What do you want to do? Say it louder.
Add 14x to both.
Add 14x to both sides. Okay, so that's what I'm going to do. You like, are you doing that because you like the variable on the left or because you like the coefficient to be positive? Oh, okay. I like that too. So 11x subtract 8 equals 7. Now I have a new equation. I know you guys think of this as the same equation, but it's not. It's what we call equivalent. It has the same solution. The same number makes it true, but it's not the same equation. And what's our justification? How did we go from here to here? What did we do? Okay. It's a property of equality. Addition, can I abbreviate? I won't. Addition, property of, okay, I got to abbreviate, of equality. That's what we did. That's our justification for going to that next step. Now what do you want to do?
Add 8 to 7.
Okay, add 8 to both sides. Wasn't that the addition property again? It is. All right, I'm starting to abbreviate a little bit more. Now what?
Divide.
Say it loud, everybody.
Divide by 11.
Okay, divide by 11. And so x equals 15/11ths, and that is the division property of equality. That's our justification for getting to here. So you're going to be solving an equation, and then you're going to be given a justification. How did I get this new equation? You'll notice I don't put a justification here, do I? I'm just doing it, right? If you show your work, don't do anything until you actually get a new equation. So on each of these equations, yeah, you need a justification for each of those. By the way, this one right here, is that an equation or the answer? It's an equation. It says, what number is equal to 15/11ths? I bet you know the answer to that question. It's 15/11ths, right? It really is an equation, but it's just such a simple equation, you can see what the solution is, right? Okay, so, but it really is an equation. So, are y'all on page 92?
Give me 1.
Right there on page 92, you have the algebraic properties of equality. We have the addition property, the subtraction property, the multiplication property, the division property. There is a substitution property, which simply says if A and B are equal, we can substitute one for the other. You've used that to solve systems of linear equations, I believe, last year. Where you would say, well, y is equal to 2x plus 5, so what can I put right there where y is? Okay, so we have a new equation, and instead of y, in parentheses, we have 2x plus 5. Now, let me ask you a few questions here. Why does that have to be in parentheses? So we use the distributive property. Okay? And why did we put 2x plus 5 where y is? What good did that do us?
Made it one equation.
Okay, it made an equation where we have how many different variables? Just one, right? Sometimes we do things and we're like, oh, well, that's got an x in it or something. We put it in the wrong place. Okay? Well, if you do substitution and your new equation still has two variables, you probably need to go back and take a closer look at that. Okay? But that's the substitution property. And then over on the next page we have the distributive property. So these are the properties of equality. So you're just simply going to be given an equation, and you're going to say, okay, I was given this thing, and then you're going to solve it, and you're going to justify each step. So what first? Distributive. distributive property of equality. What next? Add 40 to both sides? Would it be okay if I showed my work like that? So negative 35W equals 70. So that's the addition property of equality. Okay, then division. So then we divide both sides by negative 35. So remember, we want this coefficient to be 1. So positive 1W equals negative 2. And that is the division property. And that's it. You're done. Got it? It's a bit of writing, but not a big deal. Is it okay I put the 1 there? We don't usually do that. You don't have to. I just want to make it clear that that's not gone. Like here, this negative 40 is gone. Because when I add 40 to both sides, that's now a 0. It's out of there. But when I divide by negative 35, that's now a 1. So that's a big difference. You'll notice up here, oh, look at these words. Remove the variable from one side, right? Remove the constant from the side of the variable. But then on that last step, we don't remove the coefficient, we reduce it, right? We reduce it so it's a 1. Some things to watch out for. Okay, let's say I'm solving this. So I think, okay, this is given. And I think it out of 7 over 1. And then so 1a. Okay, did I just use the multiplication property of equality or the division property of equality? Okay, we're going to vote. Who says multiplication property of equality? Who says division property of equality? Who's too chicken and didn't vote? Yeah, I saw that. I can see an argument, but I think we're dividing. Right? How do you divide by a fraction? You multiply by its reciprocal, right? So, yeah, there you go. So on that one, I hope you would say the division property of equality. One little thing. We can't abbreviate substitution and subtraction the same way. Can we? So if you're going to abbreviate them, you've got to do something different. Like, okay, that's going to be substitution, and then maybe that's subtraction or something to let me know which one you're talking about. Okay? You guys are so quiet today. What's going on? Heavy lunch? Now you need a nap? Yeah? Okay. Can I make you a little more unhappy now? You guys are going to feel so smart when you get out of this class today. Solve for R. Ooh. Who's done this kind of stuff before? Ooh, good. Awesome. Okay. When I'm solving for R, or any variable, I'm going to go through the same steps. I'm going to get rid of the parentheses. I'm going to add like terms. I'm going to make sure if I'm solving for R, I don't want it on both sides of the equal sign. If I'm solving for R, I don't want them on the same side of the equal sign. I want them to move over. And I want R to have a coefficient of 1. So all those steps that we always use to solve an equation, they're going to stay the same. Okay? So I am now going to remove the parentheses. Ready? You watching carefully? I'm even going to do it in red. Now, did I just get rid of the parentheses? Are they necessary anymore? They don't need to be there anymore, do they? So, I didn't use the distributive property, but I did remove the parentheses, didn't I? Now what do we need to do? Did I tell you we're solving for R, right? So, okay. If I add 1 to both sides of this equation, excuse me, subtract 1, wouldn't it look something like that? So what property is that? Subtraction property of equality. Okay, I've solved the equation for R, and I've justified my steps along the way. Okay? Now, let's say you see something like that and you're like, parentheses, I have got to use the distributive property. P times R plus P times 1. Okay. Distributive property of equality. No more parentheses. Sweet. Okay, now I got to solve for R. Can I add any like terms? Do I have R's on both sides of the equal sign? Do I have terms on the side where R is that don't have an R in them? Gotta go. See that P right there? It's gotta go. I'm going to subtract it from both sides of the equation like this. So P times R equals N subtract P. So subtraction property of equality. Now I don't want PR, I just want R. I want 1 R. Can we make that happen? All we have to do is divide both sides here by P. What's going to happen to this P and this P? They cancel, give us 1, right? So 1R equals N subtract P over P. Now, when we solved it the other way, we got N over P subtract 1. Which answer is correct? Okay, they're both correct, aren't they? When this says N subtract P over P, this fraction line, it's a symbol of inclusion like parentheses. And what it's saying is everything has to be divided by P. So what this means is N divided by P subtract P divided by P. Does that make sense? Isabel, does that make sense? Awesome. Okay. You got a 1 right there. Y'all good? So sometimes you guys can do things a little differently. It's still good. Should we do another one of those, or are you just super smart now? Super smart. I thought maybe you'd like to see the Fahrenheit Celsius temperature. You want to see another equation where we're solving for a different variable? I think we better. Some of you look super smart. Some of you look wrinkly foreheaded. So, let me think. Okay, I got to think about this. Celsius. I think you take the Fahrenheit temperature and subtract 32, and then the answer is always going to be a smaller number than that, so we must multiply by 5/9. Okay, this is how you convert from Fahrenheit to Celsius. You put the Fahrenheit temperature in, you subtract 32 from it, you multiply the answer by 5/9, it tells you the Celsius temperature. So in our classroom right now, it is a whopping 72 degrees. Subtract 32. You got to hit enter because you got to make sure it does that bit first. It's in parentheses. Multiply by 5/9. 22.2 degrees Celsius. Simple enough? Okay. I want to solve for F. Solve for F. How likely are you to see this on an SAT or ACT? Yeah? Okay. What's the first step? Okay, get rid of the parentheses. Now watch how I do this. Oh wait, given. Watch how I do this. I multiply both sides by 9/5. What happens when you multiply a number by its reciprocal? What do you get? You get 1. Even if the number is negative. Even if a number is negative, if you multiply by its reciprocal, you get positive 1. Right? Okay. So, I just removed the parentheses. Right? Now what? Say it louder.
Add 32.
Add 32. Yeah. If I add 32 to this side, it'll be gone. Add it over here. Addition, property of equality. Done. You want F on the other side? What's my justification for that? Did you know there was a reason you could do that? I mean, if A equals B, then does B equal A? It better! Don't you think? Tatum, don't you think it better be true? That better be true. If that's not true, everything you have learned in math so far is a giant lie. Don't you think? Okay. Turn to page 94. We might be able to shed some light on this particular thing. Can you find that somewhere on page 84? Does it have a name? Symmetric property of equality. Okay, that is the symmetric property. And it just simply says that. Okay. Check out the reflexive property. What does it say? Yeah, it says A equals A. I can always remember that one. The reflection, when you look in a mirror, don't you just see the same thing? So like, you know, you equal yourself, right? So reflexive property, I can remember that one pretty well. And then we have the transitive property. It says if A is equal to B and B is equal to C, then A is equal to C. True? What was that?
It's like the law of syllogism.
It is like the law of syllogism. The law with the silliest name.
It's fun to say.
The funniest law. I don't know. Okay. So, oh, now where was I? Where the heck did that go? This. What's our justification then to go from here to here? There you go. And this is a property of equality because These are just numbers. We're just talking equality. But you'll notice on page 94, there's a reflexive property for real numbers. There's a reflexive property for segment lengths, and then also for angle measures. Now, segment lengths and angle measures makes perfect sense because segment lengths, here, if AB, if its measure is equal to the measure of CD, then the measure of CD is equal to the measure of AB. That's easy because we're talking, these are just numbers, aren't they? Isn't the measure of something just a number? And it works for real numbers. What's a little different though, if segment AB, ooh, I don't know if they do this one yet. We're going to do it. If segment AB is congruent to segment CD, then segment CD is congruent to segment AB. Here we're not talking about numbers. We're actually talking about the actual segment. Does that still seem true? Yeah? We'll talk about why that is particularly very soon. You are so smart now. Do you feel smart? Good.